Alright, so I wanted to take some time and start going over a couple of other examples and applications of our stoichiometric calculations. One being, what do we do when we're given volume or we need to find volume? The other, what we need to do when it comes to molecules. Now, we won't use either of these very often, but it is a good concept to have in mind, and you will see it on your test. So let's go ahead and get started. Now, we're given the equation 2 sodium chlorate. When it decomposes, breaks down into 2 moles of sodium chloride and 3 moles of oxygen. You're given the fact that you have 874 grams of sodium chlorate, and this will produce how many liters? This is what we want to set out to find. So I went ahead and wrote my 874 grams sodium chlorate as my given. Next step, just like I did before, I need to convert it into moles. So I need to know my molar mass for this. So we know 1 mole of sodium chlorate, if you're taking the time to find it in your calculator, should have a mass of 106.44 grams. Now, at the end of this step, this leaves me in moles. Now I got to transfer that to my moles of oxygen because that's what I want. Going back to our mole ratio, moles you want divided by moles you have. So 3 moles of oxygen is what I'm supposed to get out when 2 moles of sodium chlorate go in. So we're going to continue from here. And now you see the reintroduction of that 22.4 liters. I told you it would come back and we're just going to do it the same way. Now, because of the fact that we're looking at this as if it's at STP, we don't have to do any extra calculation to determine what that number is going to be. It's still going to be the 22.4. Now, once I've put that into my calculator, I'm going to come out with an answer of approximately 275.90 liters of oxygen will be produced. This is something we want to pay attention to because you never know, when you're actually going to be seeing this again. We still have gas laws and different things to cover, so just keep that in mind. Now, in class, you'll also get a couple more examples of this, so don't worry if it seems like it's going too fast. Go ahead and if you need to rewind, pause at the different steps to make sure you understand what's going on. Now, a second application of this will be in terms of if you're given a certain number of molecules, how will we proceed from there? So, given the equation, again, your problem's there at the bottom of the screen. Sodium oxide plus water is going to give us 2 moles of sodium hydroxide. Now, how many grams of sodium hydroxide will 8.39 times 10 to the 23rd molecules of sodium oxide produce, or is produced from this amount? So, still setting up the same problem. Our equation is already balanced, so we don't have to worry about that. Writing my given in its place. And now moving into the next part, which is I need to convert this into moles. Either way, I have to go through moles. So, 1 mole of sodium oxide, just 1 mole of anything, contains 6.02 times 10 to the 23rd molecules. This is something to keep in mind. It's still back to what we did before, so it should not be too much of a shock or surprise. Next, into our mole ratio, we see that I'm supposed to get 2 moles of sodium hydroxide for every 1 mole of sodium oxide that is put into the system. And last but not least, because I'm going to grams, I need to then use my molar mass. So 40 grams of sodium hydroxide equals 1 mole of sodium hydroxide. Taking this and placing it into my calculator just as we did before. Multiply by everything on the top, multiply everything on the bottom, and then divide. I'm going to come out with a final answer of 111.50 grams of sodium hydroxide. So this seems like it's actually a sizable amount for this substance or this sample that you have received. Now, go ahead and take some time. Again, rewind, pause, do whatever you need to do. Make sure you understand what's going on, and we're going to do some more problems like this in class. Have a great evening, and I look forward to seeing you tomorrow.